so
I like it, actually.
we did that. I don't think we have any questions about that, but variables. So does everybody remember how to make variables? So if people have that Scratch document open, or could somebody show me how you make the variable?
Let me get that Scratch document open.
Or
It's just const, const, without the AT.
without it.
Take out the, yep, there we go.
I just showing the different ways to do it. Variable, constant.
Right, so you'd have the variable, a keyword, and then you'd have the name, right? Okay, and then what comes next?
No?
Perfect. And you can optionally put in type,
Right.
or you could do that.
8 meaning bit. What was 8 in there for?
Yeah, so 1 byte.
Okay.
Sometimes that's useful. Typically, you would, if you wanted to do that, you'd use byte. Okay, what are other ways we can make a variable?
Other ways we can make what?
A variable. So if we had a function,
The variable name, colon equals, and then the value, if you're inside a function.
perfect. Okay, so what would be the type of this variable?
Boolean.
Perfect. So if we wanted to write out that full, you would use typical. It's just, yeah, except it's just bool. The keyword's B-O-O-L, not bool. So for the type. But yeah, exactly. Any other ways we can do this? Because I showed you a couple others.
You mean like the flip 64? Like,
So what if you wanted to create two variables? Say we had an x and a y coordinate.
comma?
Yeah, so if you use the parentheses way, it needs to be on another line,
Okay.
and then you use just equals, and then you don't need the comma.
Gotcha.
So that would be if you use that way. Now, you'll see this often, this approach at like the top level. That's very common in Go code. It turns out you can do this inside of functions too. That's less common, but you can do that. Okay, and then here's this multiple assignment. This is sometimes handy, 2 or 3, but once you get beyond 2 or 3, it gets out of hand. So sometimes it's better just to be more explicit. Because otherwise, it'll start to be hard to say, oh, 42 is going to n. This case is easy. Okay, so these are all getting a type, right? And so the thing about variables, right? If I wanted to change the value of n here, how would I do that?
Change the value then?
Of n or m. Perfect, right?
Yeah, because you couldn't change it to a string. 'Cause
That's
once
right.
Once you got initial you can't reassign it to a different type.
Yep. Yep, those are all good things. Did I explain this one? Anybody confused by the plus equals here? Everybody understand that?
Take whatever is in the value of n and add it to whatever's on the other side.
Yeah, so it's like putting the n here, so this is like, this part is the same as that. And it's just super common to have to do plus equals, so that's why it has that. You can do that with the other operators too. You can do star equal, you can do division equal. I've never done remainder equal. I suppose that's possible too. Okay, so that's, just remember, you use equal for assignment and colon equal for initialization. The other bit we should probably cover again is scope, right? Does everybody remember how scope works?
So if it's at the top, it's kind of what we consider global in JavaScript?
Kind of. So
Okay.
if it's at the top level, it's package, it's for the package. So package.
Oh, that's right, yeah, the directory, right, whatever is in the directory?
Yep,
Yeah.
exactly. So any files inside that same directory could access your role. Now, if I wanted to access it from another package, it has to start with a capital letter. And I didn't really cover that, but we can see that in the examples of the packages. So when we looked at math, there are some constants in here. Notice they all start with capital letters. So you have to start with a capital letter if you want to be able to access it from another package. Now the programs we've been writing are just command line programs. So we're not using them from other packages. So it doesn't matter that much to us. But once we start creating packages, then it matters. So if you want something in a package to be usable from another package, it has to start with a capital letter. Okay. So that's variables. I think
I
that's,
got a question about variables.
yeah?
Constants should be all capitals like this, miles to G.
No, they should not be.
They should not be.
The convention in Go is just like any other variable.
Camel cakes.
Yep. There are some examples in the standard lib which are sort of in that all caps, but that is not what they intended.
And when you declare outside of the function, you need to use either var or const, right?
That's right. You can't use this form outside of the function.
And will it infer the type, like right here?
Yes.
That will infer type, so
There's
you
no-
don't need to say the type. And to finish out miles to constant, if I wanted to make that some sort of an int, like int 32, int 64, what's the common use, or just straight up? You said there's one that infers it. What was that one that infers? It was if you're on a 64-bit machine, 64. If you're on 32,
Int or uint.
and it's just straight up int. So that's probably what people is that what they
That's
use
normally
most,
what you use. Yep.
most commonly, and so that'd be like 75 or whatever.
Exactly. Now you have a question?
Why can you use the colon equals?
So the reason you can't is because remember, this code is sort of not being executed, it's just sort of declaring. And this is like doing something, it's a state. So this is like create a variable and then get a value. So, and I think there's an ambiguity with the grammar that requires you not to be able to do this. So, but it's just a subtlety. You can't use the colon equals at this level.
Oh,
It's just inside the function.
so the outside variables for the first one.
Yeah, you just have to use the longer form outside of the function. Yeah.
A constant variable does not have to start with a capital letter. It needs to start with a small letter.
That's right.
Okay.
And you want to start it with a small letter if you only want to use it in this package, and the capital letter if you want to use it from other packages.
Okay. What's the byte type? Is that type?
Yeah, so that's the same as a uint8. So it's an 8-bit integer, unsigned.
Okay, I get that again. So you say it again?
Yeah, so it's the same as,
You with 8. And what is, oh, that's an 8 byte,
8-bit unsigned integer.
8-bit
So 1 byte.
unsigned, is it?
Yeah.
Oh, right.
So a number between 0 and 255.
Okay. And what is it if it is signed? What's it called?
If it's signed, it would just have int 8. And in C, that'd be an S byte, I think.
All right.
But we're just doing it. The reason why there's a special byte type that's just like an alias, it's the same, is because bytes are super useful. They're used all over the place. So, whereas you don't often use uint8, or even more unusual 16. You rarely see that. Okay, so that's variables.
Are those, did I get the types right there? Come down just a little, Boolean string and byte 164. Those are the ones we normally use, right?
Yeah.
What do you have anything? Oh, it's bool, thank you. that's the right capitalization for string and everything.
I mean, that's pretty much it. Let's look at the spec and see if we're leaving
Yeah, just
anything out.
checking that out.
We'll cover all these other array slices and stuff today. The basic ones are there. That is cool. Yeah. Bool can have a value true and false. True and false are predefined constants for the bool. So, true and false. Right, and so there's some others, but basically those are the ones you use. These, the uint pointer, will cover that with pointers. And then there's arrays, slices, maps, and other things that we'll also cover. Okay, that's the basic, the variable. You're right, these are the basic types. Okay, so can somebody tell me what a string is and how it's represented?
What a string is?
Yeah, what a string
Series
is.
of characters and alphanumeric characters.
Uh-huh.
That aren't numbered?
And what else? Is there another part of that? Sorry.
And how is it represented?
Oh, in the machine.
Yeah, like,
At a low level.
so for example, in JavaScript, a string uses 16-bit characters using a UTF-16 encoding. So how does Go implement strings? Does anybody remember?
I want to say binary. Or is that in stuff?
One binary, two
No.
binary.
UTF-8, that's right. So UTF-8
Oh,
is...
that's right, because the creator created UTF-8, right?
Yeah, exactly.
Got it.
And so UTF-8 it has a single byte for ASCII. And then for characters that aren't ASCII, ASCII ASCII is the standard encoding for text
Right.
in English. For things that aren't ASCII, it will use 2 or more, so it could use 2, 3, 4 bytes to represent that character. The actual implementation of that's kind of complicated. You don't really have to worry about it too much. But the other thing about a string in Go is that a string in Go has a length. Okay, because strings in C don't have a length. The length is indicated by a terminating null byte. So in Go they have a definite length, and that's the same as JavaScript.
How do you do it?
Huh?
How do you call the length?
That's no, you do len and you call it like a function, and that's like Python to get the length of the string.
And that would, if that would, you said, does that return the bytes or it returns the number of characters? Like, so that would be 1, 2, 3, 4, 5, 9. That would be 10 characters and bytes because each character is a byte at this level.
Yeah, let's look at an example to see the distinction there. I'm trying to find, they have text in here. Actually, here we go. Okay. So let's see what this does.
I don't read Chinese, Caleb.
Don't have to. I don't either.
There's an app for that.
There's an app for that. Google Translate. It's perfect. Okay, so here's a string that has characters which aren't English in them, and we'll see what happens if we get the length of that, okay? So,
So we got,
Oh, so it's going to count the
13.
13.
So,
5,
1,
6,
2, 3, 4,
Wow, interesting.
7, 8, 9. So why is that not 9?
Yeah.
Right.
Some of those characters are multiple.
That's right. They're multiple bytes, okay? And those are probably 3 or 4 bytes. And that's why the length is the number of bytes, not the number of characters.
That's cool.
Yeah, so that's just something to keep in mind. Like I said, though, it's actually pretty rare to have to care about that.
Yeah.
Like you never tell the user, hey, your string is this long. Like that's not a very typical thing to do. So it doesn't usually matter that much. The advantage of UTF-8 is it just plays well with other technologies. So if I'm just like looking at strings like over the network or something, really easy to see. When they're in a different encoding, it's harder because they don't look the same. So it's really nice to just be able to see strings. And we saw that when I did that hex dump example, and I dumped a huge binary, and we could find the literal string hello world inside of there, because they're just bytes, and that's what they look like in the hex dumps.
So the fundamental question, sorry, but the difference between UTF-8 and ASCII would be the number of characters it represents.
Yeah, so ASCII is 7 bits, so it can only represent 128 characters.
The last one is a check, is that right? Or is there, because I always thought ASCII had 8.
So what happened when you have ASCII, and then you have all these other encodings that different, like Microsoft has one, and OS X has one, and everybody has their own version. And the extra other characters available, the other 128 or whatever characters that you could have available for that other bit, they mean different things in those different encodings. So in Windows, that character may mean something different than in Linux. Okay? The advantage of UTF-8 is it's consistent. Everybody knows what UTF-8 means because it's well defined. So it was a good decision on their part.
And it represents more languages.
Right. Theoretically, Unicode can represent any language. So, okay.
So it returns number of bytes.
Number of bytes. That's what the length means. Types. Okay, so those are strings. That's the basic idea of strings. What are things we can do with a string? So, we can print it out. We can get the length. What else could we do with a string?
Concatenate with other strings or
Yep.
inits or
So how do we concatenate strings?
plus.
Perfect.
I only
Okay.
know that because of JavaScript.
Yeah, same as in JavaScript.
Yeah, we haven't done this yet.
What we have done is we've done something like slicing. So we use square brackets, right, to get a single character out of a string. Can somebody show an example of how that works? Okay. So, yeah, which letter? Yeah, there you go. Okay, so that gets the second letter from the string.
0.
It actually gets the second byte, which because of the Chinese example I showed you matters, right? So now, if you actually did need to get the number of characters, there's a package you can use to do that, which will treat your string like all the characters, not just as bytes. The reason we do bytes is because that's generally all we care about, and it's way more efficient. Because if you actually have to parse it as characters, that means you have to walk through the string and inspect each one to see how big it's going to be. And so this is super efficient. If we had to use characters, it would not be efficient. So that's why I use. But like I said, there's a package which would let you do it if you had to.
In English, do you ever run into a single character not mapping to a single byte?
Yeah. If you use a punctuation, like some of the punctuation, some characters that might have accents and things, you run into it occasionally. But
that could be a kind of tricky error to find.
yeah, it might throw you off. But like I said, it's pretty unusual for it to matter. But yeah, it could throw you off. Okay, so that's strings. Integers. So what are some things we know about integers? How are they represented on the computer by Go? Numbers, right? So they can be perfect. Okay, and so what kind of things can we do with an integer?
Math.
Math, right? And so what are some of those, and they call those operators, so what are some of those operators?
Division,
Plus, minus,
addition, subtraction.
Yeah, and actually if we want to see a full list of all the things we can do, it is in the spec. And we didn't cover all of the operations because there's some in there that are for people who are not used to using them. Can be pretty. This is the golang.org/ref/spec/ref ref. So we can see that. Can you read that? /ref/spec. But you can get to it if you go to golang.org and you can browse to it. And like I said, it has all of the details. So we want to see, here's a list of all the arithmetic operators. So we have addition, subtraction, multiplication, division, and a remainder operator. And it tells you what you're allowed to use them with. So notice you can't use remainder with a floating point number. So, and then there's these others. These are things we do not talk about. These are sometimes useful. I think for web programming, pretty rare you need to use bitwise operations. So I'm not going to bother covering them, but just know they exist. And this is the reason why when you use and for like an if statement, it's 2 ampersands and not 1, is because the 1 ampersand is this bitwise and operator. Okay?
What is bit?
So it treats the number like so if we had a number, you know, it treats it like the bits instead of as a number. So if we were doing OR, so if we did the pipe operator, right? So if we OR these two numbers together, we would have 0, 0, 1, 1, okay? Because OR means if either one is 1, then it's 1. Okay? If we were ANDing them, we'd end up with, you know, if we did AND, we'd have 0, 0, 0, 0, because there's no case where the digits are the same, right? And so this is the number 1, and this is the number 2, okay, in binary form. And when you, so if you were to do, this is 1, 4, 2, which is 3. So anyway, you get, they're not often used, but occasionally they're useful for certain tasks. We use them for flags sometimes. Like if you want to say, you want to store like a bunch of flags. That's a good example of a flag. Like the source.
Logged in, not logged in.
Yeah, that kind of stuff. You might have logged in, not logged in, and that might be, you might use 1 bit for that, and then
Read permissions.
exactly. Yeah, actually, the permissions in Unix is probably a good example. So in Unix, a file you can you have read and write and other permission things too, but we just care about these two for now. And so you could store it as 2 bits, right? So this would mean no read, no write, and then if you did like say 0, 1, that might mean read, no write, and then if you did 1, 1, read and write, you could take it. So you're using them as flags. And then if you wanted to check, do I have read access, you'd say, you'd say like, if there was a variable access, and then you'd say and 1, okay? Greater than 0, or something to that effect. So that's some place where you use them, but not that often. So I'm not really going to cover them too much.
We'll typically use booleans instead.
Yeah, it's just easier. We'll use a structured data type and a boolean, which is way more clear what it's doing. But it is very efficient to use these. So, because the computer does these kinds of things really, really fast. Okay, and these kind of things not quite as fast. So, people as an optimization often dive down into those too. So.
Caleb, is this Boolean or is this strict, not bitwise, like 777 Boolean? These like permissions for each of it.
These are bitwise for integers. They're only for integers, not for booleans. Yeah, so for example, you can left shift and right shift to multiply or divide by 2. It's kind of an odd thing. But it's like adding and removing a 0 in our base 10 number system. In other words, we can multiply times 10 really easily, right? We could add 0. In the same way on a computer, you can multiply times 2 really easily. You just shift it. Okay? So sometimes you use it, not that often. But that's about it. I mean, those are all the operators for integers. Basic math stuff. And like I said, the only one that was unusual was this one. Most of
Use
them.
bitwise, basically, it's signaling to other people you know what the hell you're doing. You're in a whole different class of programmer from the vast majority of programmers.
That's only really used for systems programming usually anymore. Most compilers will actually do that optimization for you though.
Right.
For a lot of this stuff.
Okay, so,
Did I get the unit 8 right, the numbers?
well, let's actually look at it. If you go to the math package, oh, I'm using this site called godoc.org. So godoc.org/, and then you give it the name of the package. And this can be any package, not just the ones included with Go. It could be packages on the internet. And so GoDoc is a great website to find docs. Okay, so it has here the max ints and max 8, all of the maximum values. And so we could reference that to figure it out. Actually, somebody want to try and write that program in here? So if we want to know what the max int 16 is, how would we do that? So it's showing you it's doing 1, shift it 15, and then subtract 1 from it. But what is that number? So can somebody write a program to figure that out? And put it in here maybe? Oops. Anybody have a guess how we start this?